Hi, Mrs McTaggart here. In this video we're going to look at exact values and related angles. Related angles are basically any angles that are greater than 90 degrees. So things like being able to find sine of 210, we're going to be able to do it without a calculator, and you're going to feel great when you can do this, because so far up until this point you've always had to use a calculator for angles bigger than 90. And the way we do it is by this thing called exact values. There are certain values of sin, cos and tan that we need to know off by heart, right? So that's what this video is all about, is how to try and remember them, and if you don't remember them, how to get them. Because I'll be honest, I don't know every single one super quick. I really struggle with my tan ones, but I'll show you how I get them, foolproof method. So we start off with two triangles here, right? We have to memorise these triangles. I always have them all up in the wall of the classroom, and I take them down whenever there's a test, but you still need to be able to draw them. And quite often pupils go into an exam and the first thing they do is draw down their exact value triangles, because it will be used heavily in paper 1 exams. So this first triangle here is an isosceles triangle with sides of 1. Now an isosceles triangle means that these two sides are the same, which is shown. And it also means that these two angles are the same. They are 180 minus 90 is 90. Half of 90 makes these angles 45. Now I'm not going to bother putting the both things, I'm only really interested in that one. One other thing we need to do is work out the slope. And we do it using Pythagoras because it's a right angle triangle. So the slope is the square root of 1 squared plus 1 squared, which is the square root of 2. So I'm going to put that in my diagram. That is our first triangle. And that lets us work out all our 45 degree angles. So you'll see in these wee boxes down here, we're going to work out sine, cos and tan of 3 important numbers, 30, 45 and 60. Now from this triangle, I'm going to put in the 45s just now. Now this requires you to remember SOHCAHTOA. So sine is O over H, cos is A over H, and tan is O over A. Now to label my triangle, opposite the angle is my opposite, the other side is adjacent, and the slope is hypotenuse. So sine of 45 is O over H, which is 1 over root 2. If I do cos, cos would be A over H, which is still 1 over root 2. So they match. And then tan of 45 would be opposite over adjacent, so 1 over 1, which is just 1. So quite often sine and cos match or are very connected. Tan's out on its own. And if you think of your sin, cos and tan graphs, you'll remember by the shape, sine and cos are similar, tan is completely different. Right, next I'm going to look at this second triangle. This started as an equilateral triangle where all the sides were 2, but because I've split it down the middle, we are just looking at this right angle triangle here with the 1, which is half of 2, and the slope is 2. Now again, we're going to do Pythagoras to get that third side. So this time it's a short side, so it's going to be the square root of 2 squared take away 1 squared, which is 4 take away 1, which is 3. So this other side is root 3. Now, equilateral triangles have equal angles. All the angles in an equilateral triangle are 60. So this one would be 60. The one at the top we've split down the middle, so it's no longer 60, it's 30. Okay? Now, I'm going to go get all my 30s next. So if I'm doing my 30s, let me just change my pen colour for a second. So if I'm focusing on my 30s, my opposite is the 1, my adjacent is the root 3, and my height is the 2. So, sine of 30 would be opposite over hypotenuse, so 1 over 2. So sine 30 is a half. Cos 30 would be A over H, so root 3 over 2. And tan of 30 would be opposite over adjacent, so 1 over root 3. Now I'm just going to change that, and I'm going to rub out the red pen, because if I'm using 60, that's now going to change my opposites, adjacents and hypotenuse. So if I'm using 60, my opposite is now the root 3, my adjacent is the 1, but my height is still the 2. So sine of 60 would be opposite over hypotenuse, so root 3 over 2. Cos of 60 would be adjacent over hypotenuse, so 1 over 2, so half. And tan of 60 would be O over A, so root 3 over 1 you don't really need the 1. Now let's look at this closely. The sine and the cos match. The tan ones are all pretty similar, but the 30 and the 60 are kind of the inverse of each other, 1 over root 3 and root 3. And we need to try and maybe think of a way that, could you memorise these instead of always drawing out the triangles? Now, a little tip I was given when I first started teaching was, if you can remember sine 30, that allows you to remember all the other 30s and 60s, because sine 30 and cos 60 match. So if you remember that sine 30 is a half, then cos 30 isn't. So, and you'll notice also that cos of 30 and sine of 60 match as well. They're both root 3 over 2. So if you know sine of 30, you know cos of 60. And then you know that the cos of 30 and the sine of 60 match. I hope that makes sense. But seriously, sine 30 is a half will stand you in really good stead to try and do some a wee bit quicker. Then there are other exact values you need to know off by heart really quickly. And these come from your graphs, right? Now, sine graph goes from 0 to 360, or 2 pi. Remember, we can change those numbers now and do them in radians. And it goes, I don't know why I wrote 0 up there, it goes from 1 maximum to -1. Your cos graph looks like that, and it goes from 1 to -1 as well. Now, if that's 360, in the middle we have 180. And in the middle of each of them again we have 90. And in the middle again we have 270. Now, I'm sorry that's really messy and squeezed in there. But from the graphs we can get all these other numbers now. So sine of 90, I'm going to change my pen. So sine of 0 is here, which is 0. Sine of 90 is here, which is your maximum at 1. Sine of 180 is your root at 0 again. Sine of 270 is your lowest point, so -1. And sine of 360 is your root again, so 1. And then you can do the exact same with the cos one. Cos of 0 is 1. So is cos of 360. That's your 2 high points. Cos of 90 is 0. And so is cos of 270. And then cos of 180 is your lowest point, so that would be -1. And we expect you to be able to do them really, really quickly. So if you just remember the graphs, it's really simple to get them and work them out. And again, I always have the graphs above the board in the classroom for quickness, but you will be expected to draw them when you come to exams. So this is just a little handy table that sometimes some people like to have. If you're in my class, I'll have this printed out and we'll put it on the inside cover of your jotters. What I like about it is this bit here I've given you in radians and degrees. Now this is useful for obviously in class, but it's not going to help you memorise them, alright? So please find a way of remembering them, practice drawing out those triangles and writing down what they are, okay? Now we're on to the next bit of it. So now that you know how to get sine, cos and tan of these very common angles, we can now do your related angles. We can now get the angles bigger than 90. And this all relies on you having a really good knowledge of this thing here. Right? Your all sine, tan, cos table. And remember, just a wee reminder, that this is always measured going anti-clockwise from 0. This is 0 degrees. This is 180 degrees. And then when you come right back round again, that's 360 degrees. And each of these boxes show you where your graphs are positive. So all your graphs are positive in all. Only the sine and sine, only the tan and tan, and only the cos and cos. Alright? And that should have been explained to you at National 5. But it's really worth remembering this table shows you where they are positive. Alright? So let's look at this next question. This kind of relies on, sometimes they throw these wee sneaky questions in at National 5. So I'm just going to talk about, is something positive or negative for each of these wee bits. So first thing I'm going to do is I'm going to just write in all sine, tan, cos. Right, I just want to know purely if each of these questions are positive or negative. So you have to think about the placement on this. And remember, we're always going anti-clockwise from 0. So sine of 60, 60 would fall in here. So if I wanted sine of 60, it would fall in your first quadrant from 0 and 90. And everything's positive in there, because that's your all box. So that one would be positive. Cos of 100 would fall round about there. It's just after the 90. So cos of 100, is that positive or negative? Well, that's the sign box. Cos is negative in there, right? Because if you think of your cos graph, between 90 and 180 is this bit here. It's below your graph. So cos of 100 is negative. Sine of 170 also falls in that box there. But this is a good one because that's the sine box. So sine is positive in there. And then tan of 280 falls just after the 270 mark. So tan of 280, it's in the cos box. It doesn't belong there, so that would be negative. And it's really important to be able to do that because it's a huge part of what I'm going to show you in the next question. So these are really, really common in various different questions at higher, okay? Needing to find the size of an angle bigger than 90 using exact values, no calculator whatsoever. So we want to find the exact value of sine 210. Now I did this in class with my class today and they were like, I couldn't believe I did that by the end of it. Sine 210, they'd never seen anything like it before and couldn't believe that you could do this without a calculator, all from knowing the exact values in the previous wee bit of the lesson. So what I want you to do is a quick sketch. Now you don't need to put the numbers in, but I've just put the 180 and the 360 there for reference. So you do a quick sketch. Where would 210 fall? So 210 would fall, let's say here, right? So you just have to draw a wee line. Now, we're doing sine of 210, so you have to decide, is sine positive or negative in that box? Now, that was your tan box, so we know it's negative. So at the moment, we know that sine 210 is going to have a negative answer, so I'm going to put down a negative. Now, we can't do 210 without a calculator, but what we do is we get this bit here, what's called the related acute angle. The angle that always takes you back or to the horizontal. So the angle between 210 and 180 is 30. So sine of 210 is going to be very similar to sine of 30. So we know it's negative, and it's going to be the negative of what sine 30 is. Now sine 30 is one of the exact values I told you to try and know off by heart. If you're struggling, remember it came from the triangle that went 2, 1, root 3, and the 30 was up there. Sine of 30 was opposite over hypotenuse, so it was minus 1/2. Okay, so let's try some more of these. And we're going to follow those steps. I sometimes accidentally, though, maybe reverse these two wee bits I do here. Okay, so let's try some more. So we're going to do tan of 120. So I'm going to do my little sketch. 120 is here. We are going to use the angle. We're interested in using the angle from the horizontal. This is your acute angle. This is what you got in your calculator before you did 180, take away it to get the 120. So the angle going from 120 to 180 is 60. Now tan is negative in that box because that's the sine box, right? So tan 120 is the same as negative tan 60. Now tan of 60 came from that triangle again, the split equilateral one. So it was opposite over adjacent, so it was root 3 over 1, so we're just going to write root 3. So tan of 120 is the same as negative root 3. And if you think, oh God, is that right? Go to your calculator and it'll tell you it is. And you'll be like, wow, I did that without a calculator. Next one, cos of 5 pi over 4. You might be thinking, oh, what's 5 pi over 4? So let's remind yourselves how to do that again. So that is doing 5 times 180 all over 4. 180 divided by 4 is 45. 45 times 5 is 225. So we're really looking at cos 225. Right, my diagram. Now 225 will fall in here. And we want the angle that takes us back to the horizontal. So the one that takes us back to 180, which would be 45. Now cos is negative in that box. So it's the same as negative cos 45. And the cos 45, remember, came from the isosceles triangle of 1, 1 and root 2. And 45 was there, so it was adjacent over hypotenuse, so it was 1 over root 2. So negative 1 over root 2 for your answer. Okay. Okay, this one, don't be put off by the negative. The negative literally means that when you draw your diagram, we're going the opposite direction. We're not going clockwise, we're going to go anti-clockwise. So we're going to go back 45 degrees. Now I should have mentioned pi over 4 is 45 degrees. So we're going back 45 degrees. So we've already got our acute angle. Okay, so is cos positive or negative in there? It is positive because that's the cos box. So cos of negative 45 is the same as cos of positive 45. And it's a positive answer, and it's 1 over root 2. And I know that because I just did cos of 45 in the last one. Then you start to have questions like this, which rely on your exact values, and we have to do a bit more with them. So a wee reminder in maths, when anything like this is all sandwiched together, it is multiplying. So we have to do 2 times whatever sine 60 is, times whatever cos 30 is. Now sine 60, remember, came from the equilateral triangle. So sine of 60 was root 3 over 2. And cos of 30 was adjacent over hypotenuse, so root 3 over 2. So when you multiply this on the top, you've got root 3 times root 3 is just 3. If you want, you can cancel out a times by 2 and a divide by 2. So you're left with 3 on the top and 2 on the bottom. So that is your answer for 2 sine 60 cos 30. And if you don't believe me, go try it in your calculator. I'm going to show you 2 more very similar to that. I know this is a really long kind of note or example in this lesson today. Right, if I ask you to work out sine squared 60, please remember that that is just the same as me writing sine 60 squared. With sin, cos and tan, we put the squared after the word part and not the number, because otherwise it looks like I'm asking you to find sine of 60 squared, and I don't want sine of 3,600, right? So the squared goes in the word, but you can think of it written like that if you prefer. Now sine of 60, we just did in that last example, 60 was your root 3 over 2. So it's asking us to do root 3 over 2 squared. So we're going to square the top. Root 3 times root 3 is 3. 2 times 2 is 4. So sine squared 60 is 3/4. This one here is just really asking us to do sine of pi over 2 is 180 half, which is 90. 3 pi over 2 is 3 lots of 90, so that's cos 270. So sine of 90 comes from your graph. Sine of 90 is your highest point, which is 1. And cos of 270 was your second root, so it's actually 0. So you've got 1 times 0, which is just 0. Now quite often these questions will also not just have a 60 in it or a 90, it might have angles bigger than 90, like sine of 120, but we've worked through all the exact values. So if you're using a TJ book, an example of stuff you could do is go to page 51 and do a selection from questions 1 to 4, and then question 5 is all based like my examples 6, 7 and 8. Okay, thank you.